this question, algorithm in order to calculate the number of nodes in a binary tree is given, and we have to find the time complexity of the above given algorithm. In this algorithm, node is defined as a structure of type node, and if node is pointing to null, that means there are no nodes in the given binary tree. Then it should return 0. Else it should return 1 plus number of nodes in the left subtree plus number of nodes in the right subtree. Why 1? 1 is for counting that particular node. So this algorithm will call this Cn function will be called once for each and every node. Let us take one example. A, B. Let us take a tree A, B, C, D, E. Now here at A, the function will be called on B and function will be called on C. On B, it will be called on D, it will be called on E. On C, it will be called twice, but it will return 0. Why? Because as C is a child node and it doesn't contain any children, the left subtree and right subtree will be pointing to null. So this on a whole, this algorithm will on a whole, the function will be called for each and every node, and for children it will be called, and for leaf nodes it will be called twice. So the time complexity would be order of n plus 2k, where k is the number of leaf nodes. So this will be order of n. So your correct option is option A. Given is a sorted array of 20 elements, that is A 1 2 up to 20 in increasing order. Determine the number of comparisons required in the worst case to search an element if binary search algorithm is used. If binary search algorithm is used, then the number of comparisons in the worst case would be log n to the base 2. So which is where n is the number of elements in the array. So this is nothing but here log n is 20, log n to the base 20, which is nothing but 4.3129 so on. So here we can say we need 5 comparisons to search the element in the worst case by using binary search algorithm. So here correct option is option C.
Consider a logical address space of 2 power 30 bytes and a page size of 1 kilobyte. If the total size of the memory required for storing the page table is 2 megabytes, what is the size of the physical memory when each page table entry also contains 3 bits for bookkeeping? So here the given data is 2 power 30 bytes of logical address space. That means in each logical address we used to have 30 bits. So these 30 bits will be divided into some page number and the displacement. The total size of memory required for storing a page table is 2 megabytes. So the amount of memory required for storing a page table is given as 2 megabytes. And then what is the size of the physical memory when each page table entry also contains 3 bits for bookkeeping? So here 30 out of these 30 bits, a page size is given, that is 1 kilobyte. 1 kilobyte means 2 power 10 bytes. So the displacement we can decide based on the page size. So the 10 bits are required to identify one entry in the page. So if 10 bits are gone for this displacement, the remaining bits in the logical address is 30 minus 10, that is 20 bits. 20 bits are for identifying a page number and 10 bits are for the displacement. And the total amount of memory required for storing a page table is 2 megabytes. That means 2 megabytes means 2 power 2 into 2 power 20. 2 power 21 bytes is 2 megabytes. Actually, in a page table, what will be stored? Number of entries of page table is 2 power 20. Number of entries of page table is 2 power 20. Okay. The total size became 2 megabytes means that means total number of entries is 1 megabyte. In each entry, we are supposed to have 2 bytes. Then only we get this 2 megabytes of total page table size. Because the number of bits required for identifying a page number is 20 bits. That means 2 power 20 entries will be there. When each entry containing 2 bytes, then 2 power 20 into 2 bytes will become 2 megabytes. This is what the given size. Okay. Then we require to know what is the size of the physical memory. Size of the physical memory is based on the, for example, if you take the physical memory, it will be divided into frame number and displacement. Displacement is 10 bits, that is confirmed, that because it is equal to the page displacement. And in each entry, we found that 2 bytes means 16 bits will be there. Out of the 16 bits, 3 bits is meant for bookkeeping. So normally in each page table entry, we will contain the frame number and bookkeeping. For frame number, how many bits are required? That depends on the number of frames. So if 3 bits are used for the bookkeeping, remaining how many bits I can use for frame number? 13 bits. So 13 bits for the frame number and 10 bits for the displacement. Total 23 bits in a physical address. That means 2 power 23 bytes will be there in the physical memory. That means 2 power 23 is nothing but 2 power 3 into 2 power 20. That means 8 megabytes. 8 megabytes. Option B is the right option here. The following two lists, list 1 and list 2. List 1 contains PQRS, list 2 contains 1, 2, 3, 4. So P is presentation layer in the list 1, application layer is Q, session layer is R, data link layer is S. The list 2, 1 is resource records, 2 is encryption, 3 is synchronization, 4 is encoding. Which one of the following is the correct match for the above two lists? So actually the presentation layer concentrates on how the data is to be presented to the destination, either in the form of encryption or decryption, or in the ASCII format or in the EBSTIC format, like that. So P is, it is encryption. Encryption is done at presentation layer in the OSI reference model. Now application layer and session layer, data link layer. Anyway, session layer is resource records. Session layer is synchronization, because whenever the session is created, the data transfer should be synchronized. Something like by creating checkpoints and by token management, we need to synchronize the activities in a particular session. That is, session layer is related to synchronization. Application layer is resource records, because domain naming system is a major activity of application layer, where it will identify an IP address for a character oriented address. That is, the resource records will be used in the implementation of the domain naming system, which is a part of application layer. In the data link layer, the leftover part is encoding, because the frame encoding will be done at data link layer. That is P2, Q1, R3 and S4. P2, Q1, R3 and S4 will be there in the option A, is the right option.